Welcome to today's tutorial on statics of solid mechanics. My name is Edem Gatogo, and in today's tutorial I am taking you through finding the gravitational force exerted on a body at an elevation above a surface. Thanks for joining me. The gravitational force exerted on a body at an elevation h is given by F equals to G times the product of the masses m1, m2 over the radius of the first body plus the elevation of the second body, all squared. And then you know the universal gravitational constant to be 6.673 times 10 exponent -11 meter cube over kilogram dot second squared. Now let's take a look at this question. Find the gravitational force exerted by the Earth on a 75 kilogram man whose elevation above the surface of the Earth equals the radius of the Earth. The mass and radius of the Earth are ME equals to 5.9742 times 10 exponent 24 kilogram, and the radius of the Earth equals to 6,378 kilometers respectively. Now, what have we been given and what are we looking for? In the question, we've been given the mass of a man to be mm equals to 75 kilogram, and then his elevation above the Earth's surface we also been given to be 6,378 kilometers, and we've been told that his elevation equals the radius of the Earth. Now the radius of the Earth is also equal to 6,378 kilometers. You convert it into meters because you are working in an SI unit, and then when you do that, you get 6,378 times 10 exponent 3 meters to be the radius of the Earth, and then the mass of the Earth is given to us to be 5.9742 times 10 exponent 24 kilogram. Now we are looking for the gravitational force exerted on a body at that height above the surface of the Earth. And then we know that formula of F to be equals to the universal gravitational constant G times the mass of the man times the mass of the Earth over the radius of the Earth plus the elevation of the man, all squared. Or since we know that the elevation of the man equals to the radius of the Earth, you just take it to be 2 times the radius of the Earth. So in that case, the gravitational force formula becomes G times the radius of the mass times the radius of the Earth over 2 times the radius of the Earth, all squared. You know the gravitational constant to be 6.673 times 10 exponent -11 meter cube per kilogram dot second squared. So you just substitute carefully your values into the formula FH equals to the universal gravitational constant, whose value is 6.673 times 10 exponent -11 times the mass of the man 75 kilogram times the mass of the Earth 5.9742 times 10 exponent 24 kilogram, all over the radius of the Earth, which is 6,378 times 10 exponent 3 plus the elevation of the man 6,378 times 10 exponent 3, all squared. And when you punch your calculator well, you should arrive at F equals to 183.7524 Newton. Or since we know 8, the elevation of the man to be equal to the radius of the Earth, and we are saying that is also the same as multiplying 2 times 2 with the radius of the earth, then we can say that the force, the gravitational force exerted on the man equals to the gravitational constant 6.673 times 10 exponent -11 times the mass of the man times the mass of the man, which is 75 kilogram, times the mass of the earth 5.9742 times 10 exponent 24 kilogram, all over 6,378 times 10 exponent 3 times 2, all squared. Then when you punch your calculator well, you should arrive at F equals to 183.7524 Newton, and that gives you the gravitational force exerted on the man above the Earth's surface at a height of 6,378 times 10 exponent 3 meters. And that is how to find the gravitational force exerted on a body at a height above a surface. Thank you.